Hey everyone. You probably missed my rant about AI, but let's dive into AI a little bit more. What I see happening in AI is a rush to product. Like they saw a small success and they're now trying to jump to something more. I'm old enough to remember when computers were just a CPU. Graphics cards didn't exist, or if they did, they were very low level. Graphics were rendered by the CPU. They took processing power to put graphics on the screen. Then as more and more graphics came, along came the GPU, which could handle all these calculations so much faster. And GPUs were actually thought of as a way of handling the mathematics to offload any math calculations from the CPU itself to the GPU, because the GPU would do the mathematics faster. It was a groundbreaking thought at the time that what if the GPU handled the math so that the CPU was handling everything else and it could push this process off to something else. But if you look at AI, they don't seem to be doing that. They seem to be trying to bundle everything together. Now, let me give you an example here. If you look at the human brain is broken down into functional sections. Like at the back of your head is the occipital lobe. If you've been reading too long, studying too much, your eyes bother you, you're going to usually feel it within the eyes and the back of the head, right? You feel like a little throbbing in the back of the head or something like that. That's your occipital lobe back there. That handles translating what the eyes see into something the brain can use. And there's a whole bunch of losses along the way, and what we see looks nothing like what a computer sees. But that's the basis behind it, okay? So that's what we've got as a baseline. Different lobes of the brain doing different things. If you've ever seen studies, and I highly recommend that if you are interested in AI, that you actually do look at some information about brain studies and things. At a certain point, they had people that had epileptic seizures. And they noticed that the seizures started on one side of the brain and crossed over to the other side of the brain. And they severed the two sides of the brain. Now, once they did that, the seizures couldn't cross the brain, so the seizures were less. But they noticed that certain things were impacted, that speech was on one side, that creativity was on another side, that logic existed in a particular area, for example. All of these pieces working together to create the whole. And if you've seen some of the higher end graphics stuff, now that they mostly on one card, but for quite a while there, you could put 2 or 3 cards together and chain the cards together, and they would share that processing. Now, how it was divvied up inside what each card did, I can't tell you. But just like the CPU handles running the input-output on the computer and all of that, and the GPU is handling the display of that information to you, the brain is broken up in a similar fashion. But they didn't do that with AI, right? They don't have an AI computer. They jam it into the hardware that we've got now, which is okay. But then they didn't segment the software, it seems, into appropriate parts. Right? If you ask your AI to do something, it basically is a jumble of stuff, and it can hallucinate when it does things. But there isn't a section on it that can put things into context, that actually handles language. There isn't a section of it that handles vision, that then hands things off to the other parts of the process. It's just a jumble of a program. And because of that, and because they saw a little bit of progress in how things were being rendered, for example, when you asked it a question about something, they went crazy. Now, a lot of this stuff goes back to the algorithms that originally were created for search engines, right? How to look up a word when a computer knows nothing about words. It does know numbers. It can put words into numbers, and it can see what numbers are typically associated with what other numbers. So if you say, I love you, it can know that I love you is typically put together. It can respond something similar because it knows where the letter, how the thing is normally structured, how things are usually put together, which is not being creative, which is not actually creating context. It's just matching a pattern, which we do very well, which computers don't do very well. It's the other thing missing. There isn't a pattern matching section of these other than trying to put numbers to words and figure out what numbers go with what other numbers. And I don't understand why these weren't built out separately, right? You look at these data centers and they're just giant GPU farms doing all these calculations, but they aren't broken down. CPU handles your input output. GPU is handling the graphical displays and possibly calculations, because that's what a GPU does well. But there isn't a section of an AI computer that handles anything, right? It's a GPU or a series of GPUs doing calculations. There isn't that same thought of let's create something specifically functional to do some process. For example, what if you created, now they've got NPUs in computers now as well, but what if you had a linguistic section that all it did was handle creating context, creating a search, or being able to handle a search of a document. That's all it does. So you've got a context section, you've got a search section. When you ask it a question, it has to look at the context of your question, and then the context of the question could be handed off to the search. And then the search could actually come back with data that could then go back through the context section to let you know the context of the response that you're being given. Seems pretty simple. I don't know why it's not being done that way, because computers process at such a speed that does not match the human brain. It is slower than the human brain, but that's something we kind of expect, right? So if that's the case, because the computers are slower, but the human brain has more specialized sections to it, it would make sense to me that if you took your time and built out those specialized sections, that it would be able to render things faster, handing things off from point to point, so that no one section of the computer is being overloaded with a particular thing. Human brains can get overloaded, right? Too much input coming in can overload us. But let's take, for example, a very, very simple process. And that was being done by Microsoft Research. And I will never, ever forgive them for apparently dropping this project. But the goal was to create a set of glasses that a blind person could wear that would let them know about their environment around them. Now, there's a complicated section and a not complicated section to it. So let's deal with the non-complicated section. A blind person could go to a restaurant and through the glasses know what the menu is. Simple optical character recognition. been done for years and years and years. Use your optics to look at the words and turn the words into something else. A digital representation, or in this case, reading the words, taking that paper object that you have, converting it into something that a computer can utilize to then figure out what the words are, and then it can, using a voice synthesizer, tell you what the menu says. Again, multiple processes here, right? You've got the first part, which is to capture the image that's in front of it and convert it into something usable, just like your occipital lobe does. A linguistic section to it that says, hey, go get what these characters mean into a word. And then a voice processing that says, okay, now that I know what the words are, I can tell the person what's on the menu. Not the most efficient way to do it, because if you've ever looked at a long menu, that's a lot of data to read. And you would need to have context that you would just want to, for the most part, know what the headlines are, right? If you look at some menus, they're just a line of what it is, right? Cheeseburger, that's it. Other menus may have more detail to it beneath the item. Cheeseburger tells you what kind of bun it's on, tells you what the cheese is on it, or gives you the cheese options, tells you if it's got lettuce, if it's got tomato, what kind of sauce is put on there, what the beef is even. But to a blind person who just wants to see the menu right now, they just need those headlines, right? The context is, first pass, I want the headlines. Second pass, I may want to know about a particular thing. And then it has to have a way for the person to tell it that it wants that extra information. It wants that next level. Because otherwise, if you think about a long menu with each item on there having a detailed description about what that item is, you're going to be sitting at the table for quite a while when you don't really care. You're looking for a particular thing. And if that assistant already knows that you have a hankering for a steak, it would not read the seafood portions of it. Okay, so a little bit more nuance and a little more context as to what the person's looking for at that state. The other part that they came up with, which was far more complex, was what do I see before me? And it was supposed to be able to take something like a kid riding a skateboard and doing tricks and tell the person that that's what was there. Right? It could read walk lights. Right? There's a whole plethora of things it could do. Couldn't guide the person, but it could show the person through words the world that's around them. Again, much more complicated than just doing optical character recognition to words. Context, another layer of stuff. Being able to interact with that assistant to get more information about a particular food item or tell it what food items you're looking for before it even reads the menu. Even more complicated. But all could be broken down into sections. Right? If you're going to tell your assistant what you're interested in, I would like to get a steak. Or maybe I feel like shrimp tonight. And I know the restaurant has shrimp. Maybe because I've already done a search to find out that there's restaurants with shrimp. I just want to hear the shrimp options that are on the menu, which, you may know already. You might have already done a search at home and have an idea of what's there. But getting there and having the menu and then saying, this is what I would like, or just, all right, I'm at this restaurant. Tell me everything that's on the menu. Just that headline item for each one. Let's say, okay, I would like to now know about the steak options. And then it could reiterate back through the steak options and give you more detail about it. You might say, stop, okay, I want to know about that particular item, however you do it. But again, now that's another module, right? The system has to be able to take input from you interpret that input, put it into a search, or put the context together so that it can go back to that search and it can go back to that reader and it can give you the information that you've asked for. Again, all pieces of a puzzle. Handed off internally, but I don't really see any of that stuff when I look at the models. They just look like they just shoved a whole bunch of things into a large language model and just regurgitate it back. And I kind of wonder why we're shortcutting the whole process. It would seem that the most appropriate way to do it would be to try to model a human brain. Human brains do a lot of things faster than computers do, especially when it comes to pattern matching. So you would think that that's what you're trying to do here. Your assistant would have to, if you had a human assistant, it would have all of those extra possibilities about pattern matching and not just be a search engine. And it seems like AI right now is just more of a search engine. Searching for bits to put together to make an object, because you asked for a picture. Searching for bits to put together for a document. But just a search engine with a way of putting pieces together that commonly go together, which is why you end up with 6 fingers. So just something to think upon while we go into the 4th of July weekend. Why is AI so hell-bent on trying to jump to the end and not build out all those little interconnections that it's going to need for real work and just trying to give you an output? And I'll let you guys think about that. And while you're thinking about that, go on YouTube. There's a YouTuber that talks about artificial diamonds being used to cool computers. And take a look at that and see what that means. I'm not going to give you too much on that one. I want you guys to go out and absorb that information and draw your own conclusions about it. But that's what I got for you guys this week. I hope you all have a great weekend, and I will talk to you next week.